The five senses. We're all familiar with them. Sight, hearing, smell, taste, and touch. As sight-focused animals, most of us think of the visual aspects of something when we try to picture it in our minds. However, this is not true for all animals. It's hard for us to imagine the way that animals who use mostly sound or smell will visualize the world around them. As well, some animals have even gone far beyond our own sight capabilities. When you think of who has the best eyesight in the animal kingdom, there's a good chance it's an owl. As most owls are active at night, their eyes must be very efficient at collecting and processing light. This starts with a large cornea, a transparent outer covering of an eye, and the pupil, the opening at the center of the eye. The pupil's size is controlled by the iris, or the colored membrane suspended between the cornea and lens. When the pupil is larger, more light passes through the lens and onto the large retina, the light-sensitive tissue on which the image is formed. Since owls have extraordinary night vision, it's often thought that they are blind in strong light. This is not true because their pupils have a wide range of adjustment, much like you've probably seen in cats. This allows them to have the right amount of light strike the retina. Some species of owl can actually see better than humans in bright light. An owl's eyes are not round like our eyes, which is why we call them eyeballs, but they instead have tube-shaped eyes that cannot move inside their head. And just like binoculars are long and help us see far away, the owl's eyes work in the same way. Owls cannot see very well up close, however, and have adapted special feathers called crines on their face to help them feel their food when it's close up. Owls are also well known for their incredible hearing, and the great gray owl can hear the heartbeat of a mouse under 40 centimeters of snow. There are a few ways owls are able to do this. Firstly, they have a large round facial disc around their eyes that funnels more sound towards their ear holes. The larger the disc in proportion to the face, the better the hearing that certain owls will have. The owl's ear holes on the side of their face are also asymmetrical, with one being higher than the other. This allows owls to triangulate the sound, figuring out where it's coming from in a faster manner, as the sound coming from below the owl's line of sight will be louder in one ear over the other. The translation of left, right, up, and down signals are combined instantly in the owl's brain and create a mental image of the space where the sound source is located. Studies of owls' brains have revealed that the medulla, the area associated with hearing, is much more complex than in other birds. A barn owl's medulla is estimated to have about 95,000 neurons, 3 times as many as a crow. Some animals, like bats and dolphins, have gone even further with their hearing to do something that we call echolocation. Echolocation works similar to sonar and is a physiological process for locating distant or invisible objects, such as prey. It does so by using sound waves created by the animal bouncing off of the object and then returning to the sender. Echolocation is used for orientation, obstacle avoidance, food procurement, and social interactions. Distance is determined by measuring the time delay between the animal's own sound emission and any echoes that return from the environment. The echoes returning to the ears arrive at different times and at different intensities, depending on the position of the object generating the echoes. The time and loudness differences are used by the animals to perceive distance and direction. With echolocation, the bat or other animal can see not only where it is going, but also how big another animal is, what kind of animal it is, and any other features. When we think about a good sense of smell, the trusty bloodhound comes to mind. While we humans have about 5 million scent receptors in our nose, the bloodhound has around 300 million and can smell 1,000 times greater than we can. You've probably seen dogs sniffing around at airports or with police officers. No matter how advanced our technology gets, it seems we can't beat the nose of a good dog. As impressive as that is, bears have an even greater sense of smell than the bloodhound, 5 times greater in fact, and can smell a piece of food that's 1 kilometer away. Next is touch. Raccoons have incredibly sensitive touch pads on their hands and will often examine their food before eating it. If you've ever seen a raccoon washing its food, it's not so much about cleaning the germs off, but rather the water increases the sensitivity of those touch pads, allowing the raccoon to better examine the food before eating it. Another animal with incredible sense of touch are spiders. They are covered with small hairs across their body that are sensitive to the slightest breeze or motion, letting the spider know when food or predators are close. Taste is another one that might be hard to imagine how an animal would have a super sense of it. But what if you could taste with your entire body? While humans have roughly 9,000 taste buds, catfish can have over 100,000. These taste buds are focused mainly in the mouth and whisker-like sensory organs that we call barbels. However, they can also be found all over the rest of the body, which allows the catfish to sense food and various amino acids in its murky and muddy environments and to differentiate among prey. If you thought we were done, some animals have developed senses beyond the 5 that we have. For example, some snakes have developed pit organs that allow them to see heat. This helps them spot the warm bodies of their prey, especially during the time of day without much light. Sharks are also famous for having electroreceptor organs called the ampullae of Lorenzini that senses the electricity that living bodies give off. This aids them in the detection of buried prey, as well as with navigation by sensing the changes in the Earth's magnetic field. It is for this reason that it is believed that the hammerhead shark has its unusual head shape, as these organs are spread out more, giving it a wider range of perception. In fact, the Pacific scalloped hammerhead are able to find geological fault lines and follow them along the ocean floor. Recently cooled magma forms rocks that have a strong magnetic signal, which the animal follows to the locations where they form congregations to feed, school, and mate. All of this only scratches the surface of the amazing ways animals have evolved to perceive the world around them. By studying them, we humans have advanced our own technology, but even then there are things that we cannot replicate and things we have only just begun to understand.